In this toolbox clip, we will look at the item most closely identified with firefighting, the delivery hose. A delivery hose is a length of flexible hose with an internal diameter of either 25 mm, 38 mm, or 64 mm. Each length is fitted with either a QRT, Queensland round thread, which has a male and female coupling, or a Storz fitting. Storz is the most common coupling used by the RFS and is a hermaphrodite fitting. That means it has no male or female end. Both couplings are the same. A key feature of the soft-walled hose is that it assumes a flattened shape when empty, allowing it to be made up and stored in a roll called a Dutch roll. A delivery hose permits water to be transported from one location to another. Water may be transported to branches, a pump, a pumper, or a water tanker. The amount of water transferred depends on the hose diameter and water pressure. Water may be delivered from pumpers, standpipes, rising mains, or hydrants. The flexibility and positioning of hoses allows water to be transferred between sites and used effectively. The Ducot datasheet contains detailed specifications, but for the purposes of this clip, let me run you through the basic construction of this hose. The 25, 38 and 64 mm are equivalent in construction and wall thickness, but as you can see, they have different diameters. In use, the hose should be 30 meters in length with a minimum of 27 meters. The hose has a weave which incorporates threads called warp and weft, which may be woven in a number of forms, such as plain and twill weave. Hoses are commonly made up of nylon, flax, cotton, or a combination of these fibers. Some may have an outer sheath of terylene or a similar synthetic fiber, which protects the jacket from wear and tear. The extruded hose, Duraline, is manufactured from PVC nitrile and is pushed over a polyamide woven jacket. This type of hose requires no maintenance, has an impermeable construction, and does not need to be dried after use, resulting in reduced water damage. This is the preferred hose used by the RFS. It has a tough PVC nitrile cover to protect the textile fibers from being damaged during service. It is also resistant to hot embers that may burn through the layers of other types of hoses, causing them to burst. It remains flexible and easy to handle at temperatures ranging from -15 degrees to 50 degrees Celsius, and has excellent resistance to oils, petroleum, and a wide range of chemicals. This tough exterior also makes it more resistant to weathering and perishing than other types of hoses, and ensures a more efficient passage of water due to a smoother internal surface. Hoses are fitted with either QRT male and female couplings or Storz couplings constructed from cast machined brass or aluminium alloy. QRT fittings are joined together by screwing an internally threaded rotating collar on the female coupling over the externally threaded male coupling. Male couplings are cast in a single piece onto which the external thread, serrated groove tail, and lugs are machined. Female couplings are cast in two pieces. One piece consists of the internally threaded rotating collar with the lugs and flange. The rotating collar has a washer at its base, and the other piece consists of the flanged tail piece. They have two projecting lugs. These assist in making and breaking the couplings. Both male and female parts include a serrated or grooved tail over which the hose is forced. Rivets and wire bindings are attached to it by glue or by glue and hose clamps. They have coarse, round threads that are used on hose couplings because of their ease of use and resistance to damage. Storz couplings are hermaphrodite fittings. They have neither male nor female ends. Adapters are available to join these hoses to hoses or standpipes fitted with QRT. These couplings have two interconnecting lugs which are joined together by butting the couplings together and screwing the fittings together. The Storz fitting is the preferred coupling used by the RFS. To begin, ensure you are wearing the appropriate PPE. It is important to always maintain safe work practices. Remember, safety first. The operation of the hose involves skills that are detailed in the Skills and Drills Manual, which you can access through your area office. Important things to know include bowling a hose, coupling a hose, and making up a coil of hose. To safely bowl a coil of hose, you will need to grasp the coil of the hose with the couplings nearest your hip. Hold the hose behind the tail couplings with one hand. Span the top of the coil with the other hand. Face the direction in which the hose is to be bowled. Take a pace forward with the outside foot and swing the coil of hose forward. Make sure you maintain your grip with the hand holding the couplings. Release the grip with the other hand. Ensure couplings do not contact the body. Note, before bowling out the hose, the firefighter must ensure the couplings are in line. This will reduce the possibility of couplings striking the body. To couple the hose, you would face the outlet and straddle the hose. Hold the tail of the coupling in one hand. Check the washer is in position and serviceable. Prepare to connect the hose to the relevant fitting. To make up a length of hose, you will need to work as part of a team of two. Lay the hose out straight, removing all twists. Fold the length in half and overlay and align the hose. If using QRT, take the male coupling to the female coupling, placing the male coupling on top. Leave approximately 400 mm difference between the two ends. Firefighter 1 should proceed along the hose within 3 meters of the folded end, or bight, and lift the top layer to add tension. Firefighter 2 begins to roll the hose tightly from the bight, working towards the coupling end. Maintain alignment and roll the hose tightly. Once rolled, ensure the washer is in position and serviceable. Note your posture and ensure correct PPE is used. Care should be taken to ensure firefighters are not injured by the sharp metal edges of the hose ties and the couplings. Damaged hoses should be removed from service and repaired. The delivery hose requires a visual examination whenever it is taken into service, once a year or after use at an incident. Broadly, the visual inspection should ensure the thread on the coupling is undamaged, the washers are in good condition, and the hose is securely fitted on the coupling tail. To begin, lay the hose out flat and straight and wash it with clean water and brushes. Check the hose and couplings for signs of damage or distortion. Fasten the hose ends. Connect the hose to a pump. During the testing procedure, and for safety in case of hose failure, clear the test area. Charge the hose with water to a starting pressure of 500 kPa, making sure you release any excess water. When the air is expelled, close the branch and increase the pressure gradually, over a period of not less than 20 seconds and not more than 2 minutes, until the required test pressure is reached. Maintain the test pressure for a period of not less than 3 minutes while the hose is examined for defects. Mark any leaks with indelible pencil. Reduce the pressure gradually. Examine the couplings to ensure that all leaks are identified and marked with a permanent marker. One final thing. There have been some instances of Class H hoses filled with wire tie fastenings and not bandit fastenings that have blown off the coupling at 2100 kPa, presenting a danger to personnel in the testing area. Take care to ensure the test pressure does not exceed 1400 kPa when testing hoses fitted with this type of fastening. We have now come to the end of the toolbox clip on the delivery hose. This clip is just one of a series of informative videos which I would encourage you to take a look at and perhaps pass on to other members of your brigade.